Hi, in this video, we're going to look at one last example of elastic collisions where two objects collide with each other and then bounce off. So here's our example. Two remote controlled cars were racing around a racetrack on a straight part of the track. Both cars were headed east. The blue car had a mass of 0.265 kilograms and a speed of 84.3 centimeters per second before rear-ending the red car, which had the same mass but a speed of 66.3 centimeters per second. After the collision, the blue car had a speed of 53.3 centimeters per second, still moving east. How much speed did the red car have after the collision? So we got a rear-ending situation here, and the blue car apparently passes on some of its momentum to the red car. Now we're going to assume that this blue car and red car is our system, and it is an isolated system, which means there's no friction or air resistance. There's no external forces that are changing the momentum of our system, such as the car's motors or anything like that. We're just assuming a simple collision between the two cars where momentum can be passed on back and forth without losing any and without gaining any. That momentum is conserved. And so because we're assuming that, our equation that represents this idea is the total initial momentum of the system is equal to the total final momentum of the system. Okay. To find the total initial momentum of the system, to really work out the speed of this car after the collision, we've got to break this down a little bit into the mass times velocity of each car. That would be our momentum. Momentum is equal to mass times velocity. And so we're going to say for the initial portion of our collision here, before they collide, the mass of the blue car times the velocity of the blue car initially, BI for blue car initially, plus the mass of the red car times the velocity of the red car initially. That will be the total initial momentum of this system. And likewise, the total final momentum is just going to be the mass times final velocity of both cars added together. So I'm writing final for these two. So now we can begin substituting in some numbers here. So the mass of the blue car, I think they have the same mass. Both of them have 0.265 kilograms for their mass. And the initial speed of the blue car is 84.3 centimeters per second. The mass of the red car is the same. The speed of the red car is 66.3 centimeters per second. All right, so I'll continue filling in the masses and the speeds. The after collision velocity of the blue car is 53.3 centimeters per second. And we don't know the velocity of the red car after the collision. That's what we're going to be solving for. So that's a lot of numbers, and we need our calculator now to put in these calculations. So 0.265 times 84.3, that's going to be 22.3. And the units here is kilograms times centimeters per second. The red car is 17.6. We're going to round that to 3 significant figures, since that's the amount that we started with, and we're multiplying. Now for the after, 0.265 times 53.3, 14.1. And then, of course, we don't do anything with this quantity quite yet. Now we're ready to do some addition, and we add 22.3 plus 17.6 on the left side of the equation there. We get 39.9 kilograms times centimeters per second. And I'll just rewrite all of this portion as well. So we're trying to solve for the final velocity of the red car. To do that, we need to isolate this variable over here. And so we're going to get rid of whatever's next to it. We're going to first subtract both sides by 14.1. So that will cancel it out here. We're going to do the same thing to this side over here. So that will be 25.8. And now we can divide both sides by our mass to figure out the velocity of the red car at the end. The kilograms cancel out. These go away as well. And so the final velocity of the red car is 97.4. And that's centimeters per second, right? Because that's the unit that we have left over right here. So that is the final velocity of the red car, 97.4 centimeters per second. So that's all I've got for you in this video. Remember, how you do anything is how you do everything.